will skip this. So when we talk about metaprogramming, there are a few sub-problems, and I will talk about a few of those. The first one is the problem of boilerplate code. So like before, let me do a step behind. And this is, well, metaprogramming is the art of programming, the activity of programming. As this is metaprogramming, we are talking about extending the compiler or extending the language and these kind of things. And now I'm back to this slide, and there are two things that we will do in metaprogramming. One problem we solve is boilerplate. Now, let's think a minute about boilerplate code. So when software developers reason about building software, we reason in terms of patterns. Like construction architects, we say, well, we want 200 of these windows, but we are not going to design every single window separately. We are not going to design separately the balconies and so on, and the frame. But we are going to say, well, here is a pattern of a window, and I want 200 of those windows. This is abstract reasoning at the level of architecture. But now in C#, there is no way that you can say, well, all these classes in this namespace, they should implement notify property change. This other namespace, it should be transactional, and this invoicing namespace, it cannot use double and float, it must use decimal and so on. There is no way to tell that to the C# compiler, because the language doesn't allow for that. That's a gap between the way that we are reasoning and the way and the language. And we have these problems with logging, transaction handling, caching, notify property change, multi-threading, validation, design patterns like builder. And that's a lot of different problems. So even if as architects we reason at a high level of abstraction, as programmers we need to work with bricks and mortar, because we don't have this kind of factory that is able to build a window for us, like a kind of 3D printer. This is my analogy. So the cost of this is that, well, higher development effort because you need to write that code, then poor quality because of copy-paste programming is error prone. But also, what if you decide to change the shape of the window in the middle of the project? Well, if you are a construction engineer, you have no way to change anything. Maybe you can do that every century or second century. But, well, as a software engineer, if the logic that builds the pattern is inside your compiler, you can change that logic. So that's a problem that we are solving. The second problem we are solving is the one of architecture decay. And here also we need to take a step back and think about the architecture role. So in the beginning of a project, typically the architect of the project or the developer, it doesn't really matter who it is, but there is this step, this phase in the project when someone decides the architecture, and we will call that the role. It's important to distinguish the role from the person, because it really doesn't matter who does that for, or discussion here. So the architecture roles produces the architecture, which means what? Well, the architectures are diagrams, component diagrams with dependencies and class diagrams. They are conventions, naming conventions, but also conventions about anything that is going to be repeated often. If you are building an ERP, a CRM, or a large management software, especially in healthcare, insurance, you can have hundreds of forms and thousands of properties. And it's important that in the beginning of the project, the teams settles on conventions. So how you settle on conventions is a management question. I will not touch these questions, but the result of that should be a list of conventions. And then the question is, how do we enforce these conventions? Well, we have code reviews, okay? Because the programmer role after the architecture is defined goes and implement the software according to the rules, but these rules are expressed as text and diagrams, and in the best case, you as developers have been trained on the architecture. Then there are these code reviews, but the code reviews are error prone. So there is this kind of broken window syndrome, and progressively the implementation of the architecture in source code is farther and farther from the original concept of the architecture. So the idea is that instead of relying on these manual processes of writing these repetitive code or verifying code, well, there are some activities, some programming activities that we can integrate into the software factory, if you like this analogy. That means the compiler, the IDE, the CI pipeline. So that's the whole point about creating a programming process. Here, I mean a management process, a human process, so that developers have a higher productivity while writing code, and also that this code is of higher quality.
Gael?
Yeah.
If you don't mind, there's a question is saying, is this something similar to create software modules using T4 templates?
Oh, yes. Yes, there will be something similar, and I will show a template, and I will show very simply the difference with T4. So yes, this is something similar, except that T4 would run before the compiler, and I will show techniques to run it within the compiler.
Cool.
But that's a good analogy. So that's why we do that. That's a sales deck, and I will skip because I don't want it to be a sales pitch. But let me go straight here. So with Metalama, what you can do is to write add-ins to the compiler or the IDE. So you mentioned T4 templates. Well, T4 templates are a tool that you run from MS-Build, and that generates strings. And here you will see that with Metalama, you can create aspects and what we call fabrics that run within the compiler, and these aspects and fabrics, first they would analyze the source code, and then based on this analysis, they would decide to transform the code on the fly and to report warnings and errors. That's one. And then a third thing on the site is that it can also provide code fixes and refactorings, but it is not a principal pillar, I would say. So we have this concept of aspect, which I will show you in just 1 or 2 minutes. And this aspect runs inside the compiler and the IDE at design time. It sees the source code, it analyzes the source code, it can decide to transform it during the build, or it can decide to report errors in real time, saying that, hey, this class must be named factory because it inherits from the factory interface. That's an example. And that's always my introduction. And now I will go to code. Let me switch to my VMware. So here you can see an aspect, and this is a template. The override method is a template method. The aspect itself is not really a template, but it is a set of templates. And here is one template override method. And here you see that the background color is a little different. It means that this part of the template is interpreted at build time. So meta is magic. It sounds like a magic keyword, and to make it sound more magic, we paint it pink, but actually this is a static class simply. So meta.target.method gives you access to the method that we are going to override. So here my template is going to write a message with the method name in the beginning. Then does meta proceed? That means execute the method that we are overriding. And then does like prints a message again. So an aspect here is a custom attribute. It doesn't need to be a custom attribute, but here it is a custom attribute. Most of the times it will be a custom attribute. So the next step is to add the custom attribute to the method that we want to log. And now I can run the application, and you see that the template, the code is executed. Okay, now what if you want to understand the code without executing that? The first thing that you may notice here is that in code length, you see that there is one aspect. When you click here, you see that there is an aspect that overrides the method, and you can go, you can preview the code, and it gives you a diff between the source code and the generated code. And this is a fundamental concept, because the source code is the thing that you're going to write manually and to store in your Git repository. This is the thing that costs you. This is the thing that you need to maintain for 15 years. Every line of this code is going to cost you 50 pounds. And that's the expensive thing. On the right part, you have the code that is executed. This is the thing that you actually want the compiler to turn into executable code. The next step that you can take if you want to even better understand the code is what if you want to debug it? By default here, I hit the F11 key, so I'm stepping inside the code. Well, by default, you generally don't want to debug the generated code because you want to focus on the business code. This is, after all, what most developers on the team should be doing, is to focus on the business code. But sometimes, well, things go wrong. Now you can switch here. You go to Llama debug, 1L please. We are Latin and Slovenic speakers, 1L for Llama debug. If the configuration does not exist, you create it here. So I switched to Llama debug. I've just hit F11 again. And this time you can see I'm stepping into the generated code. Okay. You can see here under the full path of this file is under Llama debug Metalama, and you see the whole generated code is there. It is there only if you select Llama debug, because it is expensive to format it properly for human consumption and to write it to disk. So we don't do it by default, only when you ask. So that was the first thing. Well, the most obvious case, logging, very simple logging, because it is a hello world example. So this is always what we start with. Now, many people think that logging is Is that everything we can do with an aspect? No, you can do much more. Here, I will take another simple example. And this time, this is a template for a retry, catch and retry aspect. There is something a bit more difficult here that you can see that this custom attribute has a property. This property is known at build time. And therefore, you see that it is colored slightly differently. Now, I can go to my program. I apply the retry aspect with 5 attempts. I ask for the preview, and you can see that the template was applied and that the bound here was set to what I wanted. Now, you can see the difference between this and T4. So one difference is that T4 is a markup language. Well, you need the special markup, which is angle bracket %. That's one difference. The Metalama templating language, which we call T# for template sharp, doesn't have any marker. It is C# to C#. So T4 is C# to string, but here it is C# to C#. So you have full syntax completion, you have real-time validation or everything. So you are writing a C# template in C# and it is validated. It works with any editor. There is no language extension. The difference with plain C# is how it is compiled, and I will show you that in the second part of this talk, of this webinar. So let's do something a bit more difficult now. Let's go back to logging, and this time I will want to have parameters because I really started with something very simple and boring. This time I would like to generate code that includes the parameter values. It's going to be a bit more difficult. So let's start. We are still in the override method template, and here you see a lot of code is highlighted differently. It means that it runs at build time, and I create an interpolated string builder. I append the type name, the method name for each parameter. I append the comma, blah 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 blah, everything. So you can see here that within the template, you have access to the complete code model. So you can iterate collections, parameters, have if. For each loops, you can do pretty complex things. So I create a string builder and then I use it like this. This part is compile time. Console.writeLine is runtime code. This is the code that I want to generate, and toValue is how I convert the build time object to its runtime representation, which is an interpolated string. In this case, you can see what happens. Now, if you find that this string is ugly, you are right, and you are welcome to improve the expression here. So templates can be more complex. It's really not just the obvious simple thing that I've shown in the first example. Next example, let's add a new feature. First, I've shown you how you can override methods. That was my first set of examples. Now I would like to introduce, that means to insert, to add new members to the target type. So I will do an ID aspect that will add a static field next ID and will add an ID property that is initialized from the static field. I add it here to this class. And you can see that like it sounds almost boring because it just does what it's supposed to do, but yeah, it actually introduces the new members into the type, which reminds me, I didn't finish my discussion about the comparison with T4. So with T4, you can, so first it runs before the build, so you do not see the code model of your project. You can see the code model of the previous project that has been built, but for the current project, it would be difficult. It's maybe possible, but it would be difficult. You will need to load Roslyn from T4. Good luck. So that's one difference. And one more difference is that T4 is able to generate new stuff, new C# classes, but it is not able to override the current code. So if you want to do something like overriding a method to add logging, well, T4 would not be able to do that.
Thank you. I have a question from Mariano.
Yes.
Can you also add, if you need and want to add more methods to the meta instance, is that something you can do?
Yes, I will show a more complex example. It's actually my next in line, and you will understand the next level of complexity, because so far I've done only pretty simple things. So now we are going to do something a bit more difficult, and you will see how you can do things programmatically instead of declaratively. So I will go to my next challenge, and I will answer the question after I comment on this one. So my challenge here is to implement the change tracking interface, which you may remember from your parents' Windows when there used to be an OK button. Do you remember? Back in the days, you had to click OK. Now everything seems to be autosave with undo. Well, and the OK button, it used to be gray when there was no change. So that means that we have this interface that is part of the .NET framework, and basically is changed means, well, should the OK button be enabled, and accept changes means, well, no, you can reset the status because the changes have been accepted. So quite an outdated interface, maybe still in use, but good for my example, because there are many things to do if you want to implement this interface. So let's think, and if you do metaprogramming, you need to start with reasoning. You would not start with code. Generally, if you start metaprogramming with codes, you are not going to end very well. You need to first start strategizing about what you are doing, because otherwise you will get stuck very quickly. So let's strategize. What do I need to do if I want to implement this change tracking interface? Well, first I will add the interface here. I will add the interface members. There are two methods. I will need to change these properties to backing field properties, and I will need to have a flag. Well, to set the isChange flag to true. So this is my strategy. Now, if you show, I will show you now the aspect that is already done, so you can see that actually this is exactly what the aspect is doing. Okay, that's not surprising. There is just one feature I added, is that I added this is-tracking changes property to make sure that we do not start tracking within the constructor, because at the moment we don't have a good way to to prevent that. So that's how I changed the pattern a little. So let's see now how we do that. And here you see level 2 of complexity. You actually see the build aspect method. This is the entry point of the aspect. So an aspect is a class. It is often a custom attribute, not necessarily. It can be added differently, and I will show you in a few minutes. So an aspect is always applied to something by definition. And the build aspect is the method that, so the entry point of the aspect, and it adds all the advice that is necessary to implement the aspect. And here you can see the advice is not declarative, it is programmatic. So I implement the interface. If it already exists in the base class, I ignore this step. I select all fields and properties, but among properties, only auto properties, that means those that can be changed, have a state. Only those that are settable, not init only, not read only fields, and not the implicitly declared ones. So I filter, and for all these properties, I override the access source. And here is my new accessor template. Let's go directly to the new accessor template. It looks very similar to the other templates. This time I compare the value of the new value to the old value. Here is how we are doing that. If it is different, I proceed. That means I'm setting the field. Well, why do we do proceed here? Well, first, because we don't know if it is an automatic property. Yeah, no, we know that is not the right reason. The reason is that there could be another aspect. You could do some logging after that. So the framework actually hides this for you. You don't need to think about having many aspects. So we proceed, and then we call onChange. I added this onChange because it makes it easier to implement for the derived classes. So here are the interface members, which I could do that as interface member. I could do that as introduced, not interface member. There's a very small difference, and that's it. So you get the idea. The build method is the thing that looks at the code. It decides which changes that need to be done, and it commands the framework to do all the transformation. That's how it works. So going back to Mariano's question, if you wanted to add more methods, well, you would have, say, a for loop, whatever you would do. Introduce method. I'm trying to get syntax completion. Yes, you would do introduce method here. You would provide a template, and then you are getting a method builder where you can add the parameters, change the parameter types, set everything, add custom attributes, and change the accessibility. You can change everything. I don't think I have a ready-made example. Let me quickly check if I have a ready-made example. Sometime I have that in my attic. No, I don't have that in my attic.
It's a nice, nice stuff.
But if you want, I can go later and show more, but I don't have anything prepared.
Yeah, no worries. There was another similar question, if you don't mind. Is there a way to combine multiple aspects in the same method? It's kind of a complementary.
Yes, totally. And let me see if I have any example. I don't have examples here, but so I will explain you how it works. So every aspect, they are ordered. So all aspects are ordered. by default, it is alphabetical ordering, and you can override this. Actually, you should override this to set the execution order. And then from this moment, it is transparent. That means that the second aspect would see all the changes done by the first aspect. So actually, well, aspects can be built independently from each other. If you are doing a change tracking aspect and a notify property change aspect, they will combine without much problems.
Thank you.
I see a question about runtime performance side effects.
Yep.
Well, the code you see is the code that gets compiled. So you are completely in control. Now, if you remember PostSharp, there was a side effect because it was not template based. It was based on MSIL generation, and it was allocating context on the heap to pass the context between the target code and the aspect. Now, Metalama is purely template based, so it is exactly what you see is exactly what gets executed. So you are going to get the performance overhead that you deserve. I mean, if your aspect is crappy, you are going to have a slow code. If you optimize your aspect, it's going to be very fast, and there is not going to be any overhead compared to handwritten code.
Makes sense.
So let me continue, and I will slip a bit to the second pillar, and this is reporting errors. So within an aspect, we can report errors. So let me, well, if you go a bit further in this rabbit hole of generating code, you will see quite soon that it is a challenge to make aspects that work with inherited classes. You need to think about that. So here we have a moderated comment that adds a property. Well, how is it going to integrate with the pattern added on the base class? Well, I took a convention that I will assume that the onChange method is defined. Now the question is, well, what if it is not defined? What if the base type implements the interface but not the method that I would like to rely on? So this is next step. This is already, you are taking the parenting hat because you want your aspect to be safe for developers who never want to hear about aspect-oriented programming or Metalama. So you want to give them a nice error message. So here, there is a bit more code. It is that I'm trying to implement this interface, and if it is already implemented, I would like to ignore. And if it is indeed ignored, I'm looking for the onChange method for that method that has 0 parameter. If I don't find it, I will report an error. Okay, so I define an error, I report the error for this target, for this class. Also, I check, is the accessibility protected as I assume. If you don't do that, you are going to generate code that will not compile. And the error message will be that your aspect has generated some bad code and you will be to blame. But if you check your preconditions properly and you report errors, the users are going to be much less confused and they will be productive. So you need to pay attention with metaprogramming and not only with Metalama, is that you are getting a sharp knife and you have the potential as a senior developer or an architect, you have the potential to multiply the productivity of your team, but you have the potential to destroy it. Because if you do something completely stupid, like changing the result of a sinus so that it returns a cosinus, well, it's possible, but it is not very smart. Or if you are taking all kinds of conditions, you're not testing your preconditions, your developers are going to be lost, and it's not going to help. And I hope they are going to blame you and not the framework, because the framework is able to do that. Okay, so we can report errors and or warnings, and this is the second pillar. So that was a side step. I will go back to the main flow of changing assemblies, or changing projects and code on the fly. And let me go back to these logging aspects, this most boring one. With logging, you probably, most definitively, you don't want to add a logging attribute to every single method that you want to log, because the case is, well, I would like to log all methods in all types, or at least all public methods. So for this, we have a concept of fabric. So a fabric is an entry point in your project or in a namespace. A fabric doesn't need to be applied to anything. It is called by the simple fact of existing in the project. So here you can read, I'm taking the project Amanger, I'm selecting all types, I'm selecting all methods. Now I could also filter them with a where clause, and then I'm adding the logging attribute where it is eligible. So why, if eligible? Well, because the log attribute is not eligible on abstract methods, for instance. You cannot log an abstract method. So it's going to be skipped automatically, because we have this concept we call eligibility. And by default, this aspect, like overriding a method, is not eligible on abstract methods. So these are fabrics. Now we can go here, and you see, yes, you see that there is an aspect here, even if there is no custom attribute. And now you see why this code length is useful, because a developer on your team who did not add the aspect, well, they know that something is happening. They can see that there is logging here. So there is a balance, an information balance. We want the source code to be clear, like how we implement logging should be hidden, at least when we don't want to see that. But the fact that there is an aspect on a method is quite often fundamental, and this is why we show it here like this. Okay, so you can go here and you can go preview transform code, and you will see that there is logging. So depending on the level of detail that you want to see, you have that, you can choose it. Okay, now I will move to architecture validation again. It looks like reporting errors, but actually there are some APIs that allow you to do it almost right out of the box. I will show you two examples. The first is that we can do that with custom attributes. And my case is that I would like to do a custom attributes for test only. Like sometimes, even if I'm not proud of, sometimes I make APIs that I really don't want anybody to use for anything else than a test. And it may make the design much worse if I tried not to have these for test only APIs. So I allow myself sometimes these kind of things, but typically what you would do is to add a comment, please call this in test only. Well, here with this namespace, Metalama extensions architecture. This is an open source extension to Metalama. You can create an attribute that tests that the target namespace, well, the namespace from which it is used, is as you expect. So here I created a constructor that has a isTest parameter, and I don't want it to be called from anything else than a test. So you can see here I have a warning. I should not be using this. And here, because I'm in the test namespace, I don't have a warning. And this is real time. If I remove this, you can see in real time that the warning disappears. So the code is checked in real time against the architecture. So just with aspect, we have one way is to do it with custom attributes where you hand pick every target, and the other way you can do is to use a fabric. Here I did a namespace fabric that exists within the internal namespace and says that the internals of this namespace can only be used within the current namespace or from any test. And you can say a reason, but the boss said no. The architect said no. So I have this internal class. I can use it from my namespace, but I cannot use it from outside of the namespace. Here I would get a warning, except in a test namespace. So this is an example. There are many rules that you can choose from. Like cannot be used from, can only be used from, derived times, must respect naming conventions. So Metalama extensions architecture API has these real-time validations APIs. And once it is in your project, the validation is in real time. Okay, well, time is running, and I would just like to mention that Metalama is made of a framework. This is what I've shown. But if you don't want to create your own aspect, I've seen a remark on the Q&A that is quite a responsibility, and yes, it is. Well, if you don't want to build your own aspects, we have been building the most common aspects, and we spend the hundreds of hours to do that. Well, hundreds of hours for each aspect. Totally, these are thousands. One of those is caching. One of those is notify property changed. So caching can be as easy as, no, sorry, these are contracts. I wanted to show caching. Caching can be as simple as this, that you add caching to a method. You add, this will invalidate this method. It will match the arguments. So the aspect is just right out of the box. It would generate the whole required code, all the boilerplate code. It will pull the dependency. Here is a new restrictor pulling the dependency. So things can get quite complex and complete, but the use of it is very, very simple. So we have caching. It supports hybrid caching, Redis caching, distributed caching, synchronized over message bus, many scenarios. Actually, we built that for PostSharp, and we ported that to Metalama. So this thing is super tested, very, very mature. We have caching. We have notify property changed, where we support things like this. We have a full name that depends on the property of a property of a property. Good luck if you want to implement this by hand. Good luck, really. Actually, we cannot do a preview, but it would look like this. No, actually, it is much worse. The preview here cannot be done because it depends on the whole project, not only on the current buffer. So if I want to see the code, I would like to go, I would need to go to Llama debug. I would take, say, Windows, Metalama, this one, I take the model, and this is customer view model. Yes, and here is the whole code that is generated where we trigger the property, we subscribe to the new value, and so these are hundreds of hours just to do this. And this is open source. You can use this for free. Okay, well,
that's quite amazing. I remember.
I think we can go and have a few questions.
Yep, there's one question.
Yeah, and then go for a second part.
Yep, now we're gonna have a break between. So Rui, you have a question from Rui, like if you have multiple aspects in the same method, then to run the business code, do I need to use meta proceed only in the last one? Or you
No,
as you...
No, meta proceed calls the next thing. If the next thing is an aspect, it will call the method with the aspect. And we are doing that. Well, maybe I can just show you because so now I have retry and logging, and I'm going to do both. Maybe there is a namespace. Yes. So now there are two aspects. You can see there are two aspects. Let's see the transform code. Well, I didn't care about well, I didn't try to order them differently. So now they are in alphabetical order. First we have logging, then retry. And you see, I didn't have to do anything. This is transparent. Yeah, and things get a bit uglier because the code gets more complex. You get some goto sometimes, especially when you have return values. So the whole point of aspect-oriented programming is what they call obviousness, that the aspect doesn't need to know to what it is applied. And therefore, it doesn't need to know that there are other aspects behind or before. This is designed so that it is safe. And this is not that's not an easy problem. Now, I started working on PostSharp in 2004, and I solved this problem properly, I believe, in 2009, 5 years later. So now when I built Metalama, I knew how to solve the problem.
Thank you. That's great. There's a final question. Milad is asking if this project is public and open source, and if there is documentation for it.
The project is public. Yes, it is completely source available. It is not open source. The core of the software is has a proprietary source, so it's available license. The plugins and extensions are open source and are free to be modified. There is an official documentation in doc.postsharp.net. You get the whole Metalama documentation. Very large, a lot of examples, but really commented examples and step by step and explaining why I'm doing this and not this. So there is a lot.
Awesome. Fantastic. All right, thank you so much for this initial presentation. I was quite impressed by what you can do with the framework. There's really a lot going on here. So